Hi, I'm Denis, and I will talk with you about Stogl Robotics control box. That's working name now because I'm not very good at names. You see at my company name, but it's not the name doesn't have to be innovative. I like when this what is inside is innovative. So that's basically a thing. The idea is we go towards robotic cell control so that I can control using ROS, have easy connection to full robotic cell, which means robot plus equipment plus all the fun stuff. And yeah, we do it on ROS2 control. And that's why I'm maintainer from ROS2 control. So during my PhD, I built this robot. That was my last topic, let's say. I did a bunch of industrial robotics things, and then using ROS control since 2014-15. Almost since its beginning. And when control working group in 2020 started, I decided, okay, now we have to rewrite this because it was a lot of pain porting controllers, connecting different hardware, exchanging sensor on different robots from different manufacturer, and this is something I wanted to change. That's why I decided to join a lot and work a lot on ROS2 control and then become maintainer. So what we are offering in my company is professional support regarding ROS and ROS2. Nowadays it's more ROS2. Extremely good specialization we have on hardware control and how to use in products ROS2, how you can optimize it for products, how you build all your deployment pipeline and so on. So we are currently 4 full-time engineers and 1 freelancer, which is often helping us in different projects, plus a few other office-related people. So what is our control box? It's basically the box you put in the middle between your ROS computer and your robot and your gripper and so on. So you have different connections to it. And yeah, that's basically it. So I think it's enough. We can drink coffee for 20 minutes now because that's it. Or maybe you're interested in all details behind it. Okay, let's go into all details. So the story will be longer, but first to get the idea, and this is something, which catches me for years. And basically, the main thing, setting up hardware and drivers is hard and annoying, and mostly annoying and annoying. It's a good business for my company, but really, I don't like to do stuff multiple times over and over again. Of course, you can cut it down to 1 or 3 days if you have deployment stuff, but it's just, it's just not worth it. So it's time-consuming and complex. We heard multiple times already, real-time issues, different connectivity issues, and so on. And especially if you want to connect industrial equipment, we will hear more in the next presentation about that. It can be pain, because you need additional cards in your computer, then how you handle all of this, how you handle different bus systems, and so on and so on. Also, it's even hard to just connect simple IOs, or usually when you start working with ROS to connect, when you want to just control few IOs, you need additional hardware, additional drivers, and this everything gets a bit complex and annoying. And let's be honest, most people don't want to care about control. They just want stuff to work. They want to focus on high-level application. They don't care which type of controller on you're using is in scaled or joint trajectory control. They just want to have it working. That's why we, on the other side, who are working on robot drivers and so on, have to do a good job. And often this ruins developers' experience from my point of view, because not many people, especially in ROS community, are actually control engineers. And when you start talking with them about different timing issues, some different control stuff, it's a bit hard. So how it came up to it? Back then, when I was doing my PhD at KIT, we came up with this version that we need dedicated machine for each robotic cell. So we started to build this based on mini PCs, sometimes with real-time kernel, sometimes not. Doesn't matter, it worked most of the time. That was most important for the research. And after that, I was seeing the same pain in the industry adopting ROS2. And ROS is just, You have to just set everything up. And then I began actually searching for suitable platform. I knew there are a few different options. There are a few industrial Raspberry Pi options and so on. And finally, 2022, I found a solution, and then it was basically, okay, now we have a platform, let's develop this, and currently we have some great projects where we can, in a relatively smaller cells, but with all possible equipment, test the whole spread of things we need at the moment. Now, just very short on ROS2 control, if you didn't hear for it. Basically, ROS2 control, I call it always kernel for ROS2, or basically kernel for your robot control, hardware control. You have hardware management, and you get abstracted your hardware. You can connect different robots. Everything is modular. You can connect simulators. Great thing is you can switch between real-time and between simulated environment and real environment very easily, and that's the idea. You get shared controllers over multiple robots in different domains, and our main customers from ROS2 control perspective are Move-it2 and Nav2 libraries, which basically use those standardized interfaces, and if you have ROS2 control driver, then you automatically get your Move-it connection to it. The same for the navigation too. If you want to use it, of course, you can add your own other applications. You can imagine ROS2 control as a toolbox with different stuff, hardware composition, abstractions, support for different communication protocols. On the other side, you have controllers, different chaining, different generic controllers. You can chain controllers together to make complex applications. We have currently some very, very cool projects in that direction with a lot of controllers behind each other. So there are also different interfaces towards ROS2. That's what you get. And one of the most important things for me, it's currently to be honest, life cycle and access management. So with many of people here, I have often these life cycle discussions where we actually also try to clearly define that because for the hardware, you really need to know what is what in which state and when you can control it, when you cannot control it, and so on. And this is actually the core what helps a lot, because basically we guarantee you that only one controller will at one point communicate with the hardware or write to the hardware, but you can read it from multiple and so on. So you don't have to do all this fuss with management on your own. Very important for this presentation, the two issues they are definitely solving, everything else is anyway integrated, is communication and protocols, and basically offers you on the other side interface over ROS2, so you can simply plug and play your application. Regarding platform, so we decided to go with CtrlX automation platform from Bosch Rexroth. Decision came up because they are very interesting into supporting ROS2 through modern design and so on. A bit more about their platform. It first offers classical automation capabilities. So this is like PLC, HMI connection, IOs, safety, motion, bus communications, connections, and so on. On the other side, you have high-level operating system on it. I mean, you have Linux-based real-time operating system with Ubuntu Core, which is well known to all of us from ROS world. And on the other hand, you also you can have applications, your own, which you package as snaps. So this is this container format from Canonical, snap application, and there is community there. Try to build also community similar to ROS community, where people exchange in the forum about ideas. You have knowledge base and so on. So there is also a lot of value and openness into it. They are also striving to do that as much as possible open source. Of course, their core product it's not, but they have to sell something and live from something. So this is classical architecture what CtrlX presents. So on one side we have here core, which is connected to Fieldbus system, so you can connect different stuff, but you can also connect it to third-party devices like HMI devices, device portal to manage different of those, to the cloud and so on. So where our story comes in, it's basically this here. So what we put the ROS2 control plus additional our proprietary software on it, so you can have the behavior you would expect, and a bit more about different devices they offer, which we are all covering. They have smaller devices called X3, which has also one Fieldbus connection, one additional Ethernet port. In the middle is one with multiple Fieldbus connections, or X7. It's a stronger device with i7 processor, quad-core, 60 gigabytes of RAM. This is already something you can do. A lot of stuff, probably path planning and similar things for simpler environments. That's something we will also test in the next month. Currently, we are waiting for this bigger device and working on the smaller device. And just for you to understand the architecture, where we are connecting and how we are connecting stuff. So their software architecture has following layers. Of course, you have multi-core CPU platforms. Then we use currently Ubuntu Core 22, so we are quite up to date. Then what we need is data layer, which we then access through our application for the Fieldbus system and so on. And here we build basically our user application. You can imagine it as one of those. You can define, you can have real-time, non-real-time applications, and so on. So which use cases do we have? First and foremost, the main use case, I don't know where the picture is, but yeah, it's 90 degrees turned. So basically, it's that you don't destroy your laptop on the robot, which often happens when you get frustrated, when something is not working, where your communication is breaking for 20th time in a day, and so on. But basically, what is the main use case? First and foremost, like the smallest use case, robot control, so that you have robust controller for individual robots, because it's dedicated hardware. That's more or less the only way, to be honest, to do that if you want to do it properly. But you can also embed it simply in the cabinet, and you can add additional connections to other Fieldbus systems. So that's actually very simple to use. There you can, for access data, this is typical application. There is also many other applications doing that, but not for ROS2. For example, that you simply access all the data from the Fieldbus system just to visualize them, just to show them in your ROS2 environment. This is also often a challenge to get all the status points, to know which sensor has triggered what. You don't have to use it for control, but to access them. And then, of course, you have machine learning and all the fun stuff which come up to it. And at the end, for us, most important is really have full control of robotic cells. It's simple connection for industrial equipment. So we are targeting to build different abstraction layers for different equipment, what you would have there. So that you can use it easy, and you can also combine it directly with PLC. So on that device you have also PLC application. So if you want to do some simpler logic and stuff like that, just put it in PLC and that's it. And that's often what is missing. Yeah. So this is now a showcase of test we have been doing just now. So you see here the device. It's controlling this KUKA robot behind. You will see this. The video is a bit slower. I show different steps. On the left side on my screen here, you can see control box software. Here I start application, which is automatically loaded into control box. It's separate PC here. And then I first have to prepare cell. So I trigger it, I'm preparing cell, waiting for connection from the robot. This is concretely KUKA ROS-I. When cell is connected, then we can start the cell, which means start all the controllers, enable it for controlling, and then later we start the application movement of the robot. This is just a small test program, but the idea here is to show the process, how this will work. Of course, usually in your application you will not see this CtrlX output. I just wanted to show it because the thing is, we'll come later to different versions. You can upload your custom application on it based on ros2 control. So the same thing with UR. So first UR will be prepared. So you see we can now read the data from UR in RViz, and then we will start a program and start moving UR, and that's basically it. So these are two of main robot manufacturers we support currently, or if you want to have something a bit more complex environments, which is one of the environments we are developing. Also additional stuff, Fieldbus connection system and so on is here one complex scenario with big KUKA robot. So you can see also here Fieldbus devices. They're currently not connected in the scenario, but they will be connected in the scenario, and that's basically it. Big robot with a lot of IOs, so definitely something very fun to do the use case. So we are currently, am I so fast? Okay, we are so. Oh, okay. So yeah, sorry. Now, what's the plan for the software is following. Many base things. So we are going here open core system. We are using ros2 control, and we are using open source drivers for this application. Maybe some of you know, you cannot currently actually prepare, let's say, the UR driver. So we have some custom versions of the driver. We will submit these changes also upstream. So we are doing also some hardware hardening basically in the meantime, and especially in the terms of lifecycle management and so on. So that's very important for me for this use case, because it always has to be clear what robot is doing, and currently it's unfortunately not 100% clear. So it's important to iron this out to the less detail. Then data abstraction layer access to ros2, this thing will be open sourced. We will first do this through ros2 control. So basically for you will be the same, because you will run ros2 control, and then you will get on the other hand, on the other side topics what you need on your ros2 computer. Deployment examples, snaps are great, to be honest, but they are quite different than Docker in some context, and it was painful to get proper deployment environment. So this is also something we will share with you, especially because we have to cross-compile this thing. But I think I figured it out. Now we can develop quite fast. But the problem is because we have to cross-compile for the ARM architecture from our PC's AMD64 architecture. It takes 3 to 4 hours, depending on application. As much as we have the binary releases, that it will be easier. Now I have to build KUKA from source, UR from source, ros2 controllers, and everything we build from source at the moment, because we have a bit custom version and they are not released. And in the middle, it's basically additional software, which will be proprietary then, we are looking additional value. Basically, all of this clear lifecycle management that you see, that you have clear signals from the system, what should be used. So for the next period, it's a lot of hardening has to be done, a lot on different drivers, checking also different setups, because we don't have yet the control stable as we would like to have. So you manage 20 days. Our goal is 1 month without any breakage. So I hope we manage to do it this year, to be honest, because we'll probably have to dig through all the ROS libraries we can imagine to get there. Then what is yet now immediate feature is data layer support and R&D version of the application. So this version application would be this what you see here, where you have already integrated multiple different drivers, and you can just upload your robot description, let's say it like that. The application takes this, does this all driver stuff from ROS2 control side, and basically you can just run your robot. This is something we want to open for R&D community to make them easier, because many research departments has this issue, and usually they don't want to work on control. They don't want to work on machine learning and other applications which you need for papers. And then on top of it, there will be specialized versions of applications. This is something I have to decide yet on the architecture, where especially for a robot type, maybe also with predefined setup already inside. This depends on the client needs. We will have different versions of applications, and the midterm goal is also that those applications are easily available from the CtrlX store, so you can basically download them and put on your platform, and they just work. Yeah. So at the end, I would just like to take very special thanks to Michael Lippert from Bosch Rexroth. He is supporting us a lot with his team to get this ROS2 support as good as possible. Also thanks to the research institutions we are connected with in Karlsruhe, KIT and Hochschule, with which we have also projects, and where we can test these things on different of their robots. You saw here 3 types of robots. They are nice, and they give us access to 10 different types of robots, which is also later interesting for long-term testing. Yeah, if you have any questions, you can contact us on our control box at Stogl Robotics D. If you also want to talk about this, want to have, demo, want to have beta application, because anyway, we are now already talking with some people to do beta testing of stuff, because testing. It's the key to get this stable. Thank you.
Okay, let's thank our speaker. We may have time for 1 or 2 short questions and short answers. Anyone who wants to? Let's start here in the middle.
Hi, Denis. Thank you for your contribution. Just a short question. What is the footprint of your Docker image?
It's not Docker image. It's a Snap application.
Okay, but you launch it in a Docker in this environment?
No. That's cool. Actually, Snaps are very cool. We can talk later, but 200-300 megabytes. Okay. So it's not really...
Okay, another one.
With all
short
drivers.
Question or so.
But I mean, the thing is, you download it once and then it runs. So you don't have to, there is nothing on the user side after download to do.
My question was actually related. So are you partnered with Bosch Rexroth in CtrlX world, or are you just providing sort of the apps in their ecosystem, or are you also planning to resell the CtrlX core IPC? So is it basically...
So there are different models. We are currently in the talks for partnerships. So this will happen. I cannot tell you exactly the timeline by the next months. The idea is also that, we want to provide application, but also if someone wants to have custom application or has some questions about ROS2 on their platform, we are there for it. We want to basically sell it later on the store. But probably for most application, at least in the first month or first years, probably it will be that we have to do some custom adjustments to enable all different stuff so you can easily integrate. R&D application can be done very dynamically, but that's something, for example, I trust Felix that will be do, or Picnic people, they know ROS very well. But it's not something you can just give into the industry. Into the industry, we have to look to have leaner, fixed application with fixed scope. But we are also partnering currently with different machining companies to see how that would look really in the industrial space with people who don't have anything to do with robotics and ROS2. So
okay, thanks. Let's thank our speaker once more.